In section 4.2, we're going to discuss how to find the optimal points of a function. This would mean over the course of some period of this function, what is the greatest possible value of the function and the smallest possible value of the function, and where do these points actually occur at? So the idea is that these points can only actually occur in two places, either at critical points and endpoints. So to understand this idea, let's begin by looking at a graph. So we're going to consider the graph of some function f of x on the interval from -1 to 3. So let's consider this graph. Here's x, and we're going to graph f of x. And we're going to look at from -1 to 3. And let's say, for instance, that the function had a shape like this. And this point here corresponds to x equals 1. Then for this function, we would say the global minimum, let's first talk about that. The global minimum, the smallest possible value of this function, occurs at this point. It's the lowest point along the graph of f of x. So we would say the global minimum occurs at x equals -1, and it's going to have a value of whatever f of -1 would be. So we would have to actually know what that output value is, but we know that that's going to be the smallest possible output value of this function. Now let's talk about the global max. The global max would occur at this point here because that is the greatest possible function on our graph. So the global max occurs at x equals 1, and it would have a value of whatever f of 1 is. Now here's what is important about this note up here, that this must happen at critical points or at endpoints. The global maximum, or this point here, that actually occurs at a critical point. Why am I saying that's a critical point? Well, if you recall, critical points are where the derivative equals 0 at. In other words, the slope at that point would be 0, and that's a critical point. So the global maximum occurs at a critical point. The global minimum, however, this point here, that occurs at what we call an endpoint, which would either be the greatest or smallest possible values, these values here, that we can input into our function. All right, so now we're going to apply that idea to find the actual global minimum and maximum of a function. We're going to find it for f of x equals x cubed minus 9x squared minus 48x plus 52 on the interval -5 to 12. So far we know the endpoints of the function because we have this interval. The endpoints are at x equals -5 and x equals 12. So those are two possible places of the global maximum and minimum. The other possible locations are the critical values. Here we're going to have to do some math to actually find these critical values. We know critical values occur where the derivative equals 0 or is undefined. So let's go ahead and start first by finding that derivative. F prime of x would equal 3x squared minus 18x minus 48. we want to know where this equals 0 or is undefined. Well, this will never be undefined. There's no value of x that we can't plug into this function. Places where the derivative is going to be undefined is typically if you're looking at some sort of function, a rational function where there's a numerator and denominator and you'd be trying to divide by 0. But that's not our case here. We don't have a rational function. We have just a regular polynomial. So we want to figure out where does this thing equal 0 at. Okay, to figure out where this equals 0 at, we always want to start with factoring. Okay, here I can actually factor out a 3 from all these terms. So we factor out a 3. And if I was to divide that 3 over, I would get 0 equals x squared minus 6x minus 16. Okay, so we factored out our greatest common factor. Sometimes you'll be able to factor out an x or an x to the 4th or something like that. But in this case, we can only factor out a 3. So continuing on, we can still factor this even further. I'm going to split this up. I can factor this into x minus 8 and x plus 2. In solving that, x minus 8 equals 0, x plus 2 equals 0. So the critical points are going to be x equals positive 8 and x equals negative 2. So our possible locations. The possible places where the global maximum and min can occur are negative 5, negative 2, positive 8, and positive 12. And so to determine which one of these is actually the global max and mins, we're going to plug those into f of x. We're going to find f of negative 5, f of negative 2, f of 8, and f of 12. So we're going to plug these back into, all the way back into the original function. If you were to plug these back into the original function, you can use your graphing calculator for this. You will get f of negative 5 is negative 58. F of negative 2 is 104. F of 8 is negative 396. And f of 12 is negative 92. What we have shown is that our global minimum, the least possible value of the function is negative 396. The greatest possible value of the function is 104. So I would say the global min occurs at x equals 8 and is negative 396. The global max occurs at x equals negative 2 and is 104. In this next example, we're going to keep everything exactly the same. This is the exact same function. The only thing that we've changed now is the interval, that we can go from negative 5 to infinity. So let's talk about our possible locations. We now only have one endpoint. The endpoint, negative 5. And then we also need to think about, okay, what happens as we go to infinity? We also have our critical points, which we found in that last example. Those critical points were negative 2 and 8. So let's look at f of x and see what's happening. we found in our previous example that f of negative 5 was negative 58. F of negative 2 is 104. F of 8 is negative 396. And as we go on forever, if I plugged infinity into this function, if we did infinity cubed minus 9 times infinity squared minus 48 times infinity plus 52, you would have this giant number, infinity cubed. So essentially f of infinity is infinity. It would just continue to rise forever and ever. So in this case, we have a global min, the smallest possible value, the global min at x equals 8 is negative 396 as a global minimum. However, there is no global max. And the reason is this function just continues to rise on and on and on forever and ever. All right, so let's look at a function that's maybe not quite as just a straightforward polynomial, but we've got a similar type of idea. We're going to find the global maximum and minimum of g of x equals x minus sine of 2x on the interval 0 less than or equal to x less than or equal to pi over 2. So the first thing that we want to find here is our endpoints. So we've got endpoints 0 and pi over 2. Then we need to find our critical points. Critical points occur where the derivative is 0 or undefined. So if I find the derivative of g of x equals x minus sine of 2x, the derivative would be g prime of x equals, well, the derivative of x is just 1, minus the derivative of sine of 2x. Well, we have an inside function, 2x. The derivative of the inside function would be 2. And the derivative of sine is cosine, keeping our 2x on the inside. So if we found the derivative of g of x, it would be g prime of x equals 1 minus 2 cosine of 2x. And we want to figure out, okay, where does this thing equal 0 at? In other words, we are trying to solve this trigonometric function. So here's how we would solve that. You actually think about solving this almost like it's a linear equation. And we're going to subtract 1 from each side. Negative 1 equals negative 2 cosine of 2x. We divide by negative 2 and we get 1/2 equals cosine of 2x. So I'm going to work this part out off to the side just so we understand what's happening. So I'm going to move this off to the side just real quick. Essentially what we're trying to find is 1/2 equals cosine of what? If you were to look at a unit circle, keep in mind cosine is equivalent to the x values, right? You would see 1/2 equals cosine of pi over 3. So thinking back to our original example, 1/2 equals cosine of 2x. Okay, I want 2x. I want where 2x's to result in pi over 3. So really what we're trying to solve here is 2x equals pi over 3. And if we multiply each side by 1/2, x is pi over 6. That is our critical point. Pi over 6. So we want to test all of these in the original function and see where the greatest and smallest possible values are. So far our possible places are 0, pi over 6, and pi over 2. Let's plug those back into the original function. If we were to plug those back into the original function, so taking these and plugging them back in here and here, g of 0 will result in 0. G of pi over 6, if we plug that back into the original function, results in negative 0.342. And g of pi over 2 will result in 1.571. So we can see now the global min is at x equals pi over 6, and the actual value is negative 0.342. The global max is at x equals pi over 2. And really, its value is essentially 1.571. Okay, so let's take this idea now and see if we can apply it to a word problem. So in this example, a grapefruit is tossed straight up with an initial velocity of 50 feet per second. The grapefruit is 5 feet above ground when it is released. Its height at a given time t is given by y equals negative 16t squared plus 50t plus 5. How high does it go before returning to the ground? Okay, so in this case, the only possible real endpoint is actually when the grape is initially tossed, right? A time of t equals 0. Well, that's not really relevant to us because obviously we're throwing the grape up in the air, so it should continue up and have a point that's going to be at least higher than our starting point. So we really only want to find the critical point here. That's our possible maximum height. So to find the critical point, we want to find the derivative first. Y prime would equal negative 32t plus 50. And we want to know when this thing will equal 0. If we subtract 50, negative 50 equals negative 32t, and dividing by negative 32, we get t equals 1.5625. Okay, and remember, we're talking about time, so this is time in seconds. That is the time when the grape should be at its highest point, 1.5625 seconds. The question is, how high does it go? Or in other words, what is the maximum height of the grape? So what we want to do is plug 1.5625 back into the original function. Y equals negative 16 times 1.5625 squared plus 50 times 1.5625 plus 5. And what we'll get is y equals 44.0625. And our units of height in this case would be feet. That would be the maximum possible height that this grapefruit could go.